we took the angle of Gaussian primes. So if the whole notion of mod categories, it doesn't really work so well for complex numbers. You can't really divide a complex number. So we needed another way to divide the primes into categories. So we did this by looking at the angle measurements of all the primes less than a certain norm, or in this case, norm squared. So the angle of any Gaussian prime is calculated by taking the arctangent of b over a. And what that means is, say we have some grid. So normally when you're graphing, you're probably used to x and y coordinates. However, with prime numbers, when we graph them, we're more concerned with, instead of an x-axis, we have a rational axis. And our y-axis is actually our imaginary axis. So say you're graphing the number 2 plus 3i. What you do is you go over 2 units on the real axis, then you go up 3 units on the imaginary axis. So when we graph that, our number 2 plus 3i would actually show up here. Right? So now there's 2 things associated with any Gaussian integer. And that's, the first thing is what we call its norm, literally its magnitude. And we calculate this just using Pythagorean theorem. So if you notice, we can actually, this line here would actually be what we call our norm squared. And on one side, we have our real number, our a, and our b. So here's our a, which is 2. And here's our b, which is 3. So we can construct a triangle. And to calculate the hypotenuse, or norm squared, would just be a squared plus b squared. So in this case, it will give us 9 plus 4 is 13. So the length of the side is the square root of 13, but it's easier to consider the norm squared, which in this case would be 13. Now the other thing associated with any Gaussian integer is what we call the angle, which would be theta. And we calculate that by taking, using the tangent of theta. The tangent of theta is b over a, or theta we say is the arctangent of b over a. So that's how we would take all these integers and divide it into different categories based on its angle measurement, and look at all the primes in a certain angle less than some norm. So this is where our presentation catches up to our current research. And I'd like to thank Professor Chinta, City College of New York, all the general HCS staff, and of course Dr. Staff. Okay, so you don't understand where we get the angle associated with the Gaussian integer? Okay, so the question was, how do we get the angle associated with the Gaussian integer? So if we go back here, look here. So when you actually graph the Gaussian integer, say 2 plus 3i, it's going to show up somewhere on this plane, right? So we say 2 plus 3i. Here, any Gaussian integer is of the form a plus b. Right? So here a is the real number, which would be 2, and then b would be our imaginary number. Our imaginary coefficient here would be 3. So when we graph it, we go over 2 units on the real axis and then up 3 units on the imaginary axis. So when we actually graph it, we can sort of construct a triangle out of it and just look at the angle that's formed with the real axis, with relation to the real axis. So here we would to calculate that, we say the tangent of that theta that's formed is the side b over the side a, and we just solve for theta, so theta would be rectangle b over a. Any other questions? Yes?
Can you explain that, again, the 299 equals p squared thing?
Sure. Okay, so what we do is we say that we're trying to test the primality of the number 299. So we say if it's not a prime, well, we can write it as at least the product of 2 numbers. Here we call them p times d. Where if assuming these numbers aren't the same, then p would be the smaller of these 2 factors. So taking this inequality, p is less than or equal to d. What I did is I just switched it, so I said that d is greater than or equal to p, and I multiplied both sides by p. So you can multiply 2 sides of an inequality while still preserving the inequality, assuming that the number you're multiplying isn't negative. If the number was negative, it would just switch the inequality. So on one side I have p times d, and on the other side I have p times b, which is p squared. And if you recall, I said that 299 is actually what I'm defining as p times d. So I replace p times b with 299. So I have the new inequality, 299, is greater than or equal to p squared. And then I'm solving for p. So p is less than or equal to the square root of 299. Now, since p is my smaller of my two factors, to find any one factor of a number, assuming it's not prime, I would test the square root of that number. So here I have to test the square root of 299, which is 17 point something. So I only have to test up to 17. If I get up to 17 and don't find any factors, that means that the number I'm testing was prime. But here, I found that 13 times 23 was 299, so 299 is not prime. Any other questions? Yes.
So when you look at graph, you're trying to understand how to determine, you are trying to really flip over.
Right, okay, so there's obviously going to be some level of symmetry when you're graphing these numbers. So I just use the number 2 plus 3i. So whenever I have the number 13, I get 2 plus 3i. I could have just as easily gotten 2 minus 3i or negative 2 plus 3i. There's actually 8 different possibilities of a prime from any rational prime. So there's going to be some level of symmetry there. So what we did is in our lab, we only had to look at all the primes that had an angle less than 45. Since the whole, the entire axis would be 360 degrees, 360 divided by 8 would be 45. So I'm only looking at the numbers where the b is actually greater than a, so that gives me an angle measurements between 0 and 45 degrees. Any other questions? Yes. Adarsha, that's a Subick. Any other questions? Yes.
Before, when you were dealing with the norms, the vector for imaginary national graph, why is it that you're more concerned with the norm squared than the norm itself?
Okay, so the actual norm of okay, so the question he asked is why am I more concerned with the norm squared versus the actual norm, which is the actual magnitude of the number. So say I'm taking the number 13, when I factor the number that I use is 2 plus 3i, right? So the actual norm of the number 2 plus 3i is the square root of 13, but that gives me a number that's not a rational number, so it's just a little more difficult to work with. So I have to take into consideration the accuracy of the number, the square root of 13 that I'm actually plugging into the computer, whereas if I use the norm squared, if I'm adding two square numbers, I'm always going to get another whole number. So it's just easier to work with